this video we're going to talk about pendulums. What we're going to do is we're going to look at solving for the period of a pendulum. So the pendulum itself is just attached down here, and the period is the total time it takes to start from one end, go to another, and then make the return trip back home. So that's one full oscillation, going from one side to the other, back to its origin. That is the period. The equation to solve for the period of a pendulum, T is equal to 2 pi times L over G, all under the radical. Now if we look at this equation, G is constant as long as we're on Earth. 2 pi, that's not going to change. So the only thing that's going to change for our pendulum is the length of the string. As the length of the string goes up, what happens to the period? The period also goes up. What happens if I put a mass at the end of the string, or a bigger mass? What changes in? Nothing. Absolutely nothing. The mass at the end of a pendulum has nothing to do with the period of a pendulum. I'm telling you this now. I'm going to tell you again in class. Please don't get that question wrong. I know you're thinking to yourself right now, no, don't get that one wrong. You're going to do fine. So let's practice a problem. What's the period of a pendulum with a string that's 1.2 meters long that has a mass of 5 kilograms at the end of it? What do I need to know about this information right here? No, I don't need that. It's trying to trick you. Doesn't matter. Doesn't matter how much mass is at the end of the string. All that matters, T is equal to 2 pi L over G. So it's just 1.2 meters long. That's all I need to know. Thank you. Divided by 10 because I'm lazy. Times 2 pi. Bleep, bleep, blurp. Throw that into my calculator. 2.17 seconds. So here's my pendulum. Starts over here. 1/1000.2.17. Back to my home. That's it. Just depends on the length of the string. Alright, the other part of this video deals with waves. So if I have a wave moving down a string, the speed of that wave is equal to the force of tension between the two ends of the string divided by the mass of the string divided by the length of the string. It's a lot that's going on here. But if you think about it, what happens if the force of tension goes up? What's going to happen to the velocity of the wave? Would also go up. But if the string was heavier, it would take more energy now to create that same velocity of the wave. So if the mass goes up, then the velocity goes down. So we're just looking at these particular relationships between wave speed, tension, and mass of the string. This equation is not on your equation sheet. And I know for a fact that you have to deal with it on your quiz. So it's probably something that you should memorize. Velocity equals F of t over m over L, all in the radical. So let's try a practice problem with it. Alright, I'm going to write my equation again just because I want to get used to writing it. There you go. What's the speed of the wave that's traveling on a 3-meter long string with a mass of 0.77 kilograms and has a tension of 90 newtons between both ends? So if I set up my problem, 90 newtons divided by a mass of 0.77 kilograms, 3 meters long, all under the radical. So in order to solve this correctly, first I want to take these two numbers and divide 0.77 by 0.3, and I get 0.256. Then I take 90 divided by 0.256, and I get 350. I put that inside of the radical, and I get a velocity of 18.7 meters per second. So try to do it each in your individual steps, because when you look at this, divided by this, divided by this, it gets a little crazy. But if you do them each in the individual steps, remember your calculator doesn't always follow order of operations unless you have like 50 parentheses in there. You should be in a much better position to get the right answer. All right, so that's it for today.